Alright guys, how's it going? My name is Sergey, and today I'm gonna talk to you about the linked list data structures algorithm, which is a powerful and popular, in my opinion, data structure in programming in general, and it might be useful for you, for any of you guys who is currently preparing to pass a programming interview, or maybe you might just be willing to to improve to sharpen up a little bit your skills in data structures and algorithms. So what is the linked list data structure? And for those of you who don't know what it means, the linked list data structure is kind of a little bit similar to an array data structure, which is widely used in many popular programming languages such as C, C++, and many others, of course. But the problem with this data structure of arrays is that arrays, especially in those aforementioned languages, that this data structure is a little bit limited in that regard, that arrays in C, for example, they can't keep track of their size, that because of that it's the programmer responsibility to keep the size of an array, and that could be a problem. And the next problem, but not the least, I would say, is that it's time and space complexity, which I'm not gonna about in this video, because it's a whole another topic in my opinion, and it's a completely different area of expertise, I believe. So, but just for the sake of simplicity, I would say that data structures such as arrays are less powerful, I would say, less flexible maybe, in comparison to linked list, for instance. And as I already pointed out, those might come up in your programming interview if you are preparing for one. But anyways, let's get started. And actually, what is the linked list? A linked list consists of nodes like this in this picture, which node has two components. The first one is data, which could be any type, such as integer, double, float, object, string, anything really, it doesn't matter. And the second part of a node is a pointer, is a memory address of another node, and that's how those nodes are connected to each other. Alright, and one important difference between arrays data structure and the linked list is that each node is located in a different memory spot, whereas in arrays, for instance, each consecutive element is located in adjacent memory location, I would say. And the only way to link nodes in the linked list data structure is through pointers to the next node. Okay, so enough babbling. And before we get started, the last thing that I wanted to mention is that the first node of the linked list is called the head node, and the last node of the linked list is called the tail. Right? It's the first is the head and the last is the tail, and the last node is gonna point to null always, right? And yeah, that's basically it. And there are a couple of useful algorithms which are related to, not a couple of course, it's a little bit more, but we're gonna discuss a couple of algorithms such as traversing the linked list, inserting a node to the linked list at the head, inserting a new node in the middle, for instance, and to the end of the linked list. Also, we can search for a particular node in the linked list. We can display all the elements of the linked list, and what else can we do? We can sort the linked list, and we can reverse the linked list, which I'm gonna talk about, I think, in a separate video, because it's a little bit more complicated than a usual, normal linked list. All right. So without further ado, let's get started exploring, implementing this data structure and related algorithms using C programming language in this example. Alright, so first of all, I'm gonna comment my code as much as possible, and I'm gonna start with absolute scratch. So first of all, yeah, let's add some comments, implementing list data structures and related algorithms using the C programming language. Alright, so first of all, we need to define our node, and in C we can use node struct structure, which is called struct. We'll define it. Struct, we'll call it node. Alright. So let's assume, for the sake of simplicity and for the sake of this particular example, right, that all our data is going to be the type of integer. Alright. And the second component of our node is going to be the pointer to the next node. It's going to be the memory address of the next node. Alright. So next, let's prototype some functions which we're going to implement in this algorithm. Alright. Function prototyping. So I'm just trying to keep my comments consistent and maybe useful for you guys if you wanna refer to them later, if you wish, of course. So first of all, we can add node to the head, I would say, right? Next, we can add a new node to the middle of the linked list. Next, we can add a node to the end of the linked list. So the next operation that we're going to implement is deleting node from a particular position. Next, we can sort our linked list, and also we can display all the elements of the linked list. Alright, that's our strategy. Let's prototype some functions. Over here, the first one is going to be, and all the functions, by the way, are going to be the type of void, because they are not going to return anything, just for the sake of simplicity, right? Add so what do we call this particular function? Add first. So this function is going to take a couple of parameters. The first one is going to be double pointer, because we're gonna change the head pointer when adding, a new element to our linked list. For this particular reason, we should use the double pointer. If you are interested in learning a little bit more about double pointers, first of all, I'm gonna show you a picture, so where we can see that in order to this is a double pointer, which is gonna point to this. Gonna have the memory address of this pointer, alright, and this pointer is gonna is gonna hold the memory address of this variable. Alright, in order to change the address, not the address, in order to change the link, right, to another pointer, to another variable, right, we should use this double pointer, but it's a little bit complicated topic, and I think that maybe I will make a separate video for you guys, so that you will be able to understand it a little bit later, a little bit better. So, but for now, I think that should do it. And also we can use data, because we adding data at the beginning. Next, we can add in the middle, and after, maybe start node, previous node, data. So the next is gonna be and the end of the linked list. Here we're gonna have a reference to the head, okay, and data as well. So next, delete our node, we're gonna pass the reference to our head, and here we can pass a key, particular key, to delete a node. Next, we should be able to sort list. I'm gonna pass double pointer to the head, and the last but not the least, of course, is we're gonna display the element print linked list. Here we're gonna pass just normal pointer to our head, because we're not gonna change its memory address. Alright, the value of this pointer. Yeah, that's the word I've been looking for. Sorry about that, guys. So let's get for now our main function, and let's implement our functions over here. Function definition. First, I should be able to add any node at the beginning. Alright. So first of all, in C, in order to create a new node dynamically, we should be able to dynamically allocate some memory on the heap for a new node. Alright, and we can do it like this. We're just gonna say struct should include standard input-output library in order to deal with input and output, obviously. Alright, and now we can use this function, size of struct node, struct node. This function is going to give us a void pointer, and in order to dereference this pointer, new node pointer, in other words, in order to assign some values and put some values to this memory location, we should cast our void pointer to the struct node pointer. Alright. Otherwise, we won't be able to assign values to our new node. Next, we should assign values to our node. Alright, assigning values to our node. So this, I'm gonna use this arrow syntax because it's a little bit more, intuitive for me at least. Alright, I'm gonna be equal to data as passed in here, and next we should point the node to the head, right? So node next equals the new node, and finally we should shift the head to the new node, right? So our head is gonna be shifted to the new node, and now our new node is gonna be the new head. Alright, so that's what this double asterisk, double pointer means. Alright, so alright guys, in the next video we're gonna continue writing our functions to implement this data structure and related algorithms using the C programming language. See you in the next video.